Alrighty, let's have a look at example 33. It's a nice question because it's a proof question. So we need to prove that sine of a plus b times sine of a minus b gives us sine squared a minus sine squared of b. So we start proofs by writing down what we want to show. So WTP we want to prove that sine of a plus b times sine of a minus b equals sine squared a minus sine squared b. So remember, when we're trying to prove things, we want to work with left-hand side and right-hand side separately, not smush them together. So let's work with our left-hand side. So left-hand side is sine of a plus b times sine of a minus b. So then this is where we flick to our formula sheet and copy down what sine of a minus b and sine of a plus b is. So I'm going to say, using from the formula sheet, sine of a plus b is sine a cos b plus cos a sine b. And we're going to use from the formula sheet a minus b, which it says sine a cos b minus cos a sine b. So we've written down what we're going to use, so let's actually apply it. So in our question, we've got the product, so I'm going to put in brackets, sine a cos b plus cos a sine b, multiplying that by the difference, which is sine a cos b minus cos a sine b. So we can then expand this binomial like FOIL. So let's multiply the first terms. So sine a cos b times sine a cos b gives us sine squared a cos squared b. So first outer, so let's look at sine a cos b times cos a sine b with a negative sign in front of that. So that gives us minus sine a cos a times sine b cos b. And then first outer inner, so let's multiply these two inner parts. So we get plus sine a cos a times sine b cos b. And then lastly, we have minus cos squared a sine squared b. So the two middle terms can cancel because it's plus minus literally the same thing. So we're left with that equals sine squared a cos squared b minus cos squared a sine squared b. So what we can do right now is turn our cos squares into 1 minus sine squares, because using the identity that sine squared plus cos squared equals to 1. So the idea of using sine squared b plus cos squared b equals to 1, or in other words, sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. We can replace cos squared b with 1 minus sine squared. So we have sine squared a times 1 minus sine squared b. And we're taking away, we're going to replace the cos squared a with 1 minus sine squared a times then sine squared b. So now we've got everything in terms of only sine of a's and sines of b's. So we just want to get rid of the cosines. Next, we can expand the brackets and see if we can simplify. So expanding sine squared a, we get sine squared a minus sine squared a sine squared b for the first part. And then for the second part, that's minus sine squared b. Minus minus is a plus, so that's plus sine squared a sine squared b. So lucky for us that the sine squared a and the sine squared b can cancel if it's plus minus. And then so we're left with that equals sine squared a minus sine squared b, which is exactly what we wanted in our right hand side. So that equals right hand side. So we can finish our proof for therefore statement. Therefore, sine of a plus b times sine of a minus b is sine squared a minus sine squared b.